This is day 4 homework. We'll be doing page 6 and 7 tonight. Today in class, you were supposed to learn quite a few things. You're supposed to learn that pH plus POH equals 14. We also in class learned that the hydrogen concentration would be 1 times 10 to the power of a number here, a negative number. That number right there would represent the pH. We also learned sometimes you're given the hydroxide concentration, which would be 1 times 10 to the negative and some number. And that number right there would tell us the POH. This is really what you need to know to complete this page. It says, what does it mean when the formula of a particular ion or molecule is enclosed in brackets? So if you see brackets with a compound, it means that that is the concentration. We used this word briefly in the solutions unit where we called it molarity. Give the formula for converting pH to POH. Well, if we know pH plus POH is 14, then converting pH to POH would be POH equals 14 minus the pH. pH and POH will always be a positive number. So, let's look at our first example. It's telling us that the hydrogen concentration is -2. That means the pH is 2, thus this is an acid. POH is a little bit harder. If they give you the OH concentration, that 5 right there is the POH. So the POH is 5. So when we look at this problem, the H concentration is 2, so that means the pH is 2. And it is most definitely an acid with a pH of 2. If they give you the OH, this number is telling you the POH. So if it's a hydrogen concentration, the exponent is the pH. If it's a hydroxide concentration, the number they're giving you as an exponent is the POH. We really only reference the pH scale to tell whether this is an acid or base, which we'll get to on the next page. So if the OH value is 6, that means the POH is 6. This is the first question that actually asks you for the pH now. In order to get the pH, you have to do 14 minus the POH, and that will give you a pH of 8, which means this is a base. So you'll notice I only label acid or base when I'm on the pH scale. This number right here would represent the pH. So the pH would be 6, which is slightly acidic. I'll let you try these on your own. We'll move to the bottom. Most of this is just the same math I just demonstrated. What is the OH concentration of a solution that has a POH of 6? The OH, remember, anytime it's brackets are going to be, whether it's an acid or a base, 1 times 10 to the negative. So if I'm looking for the concentration of hydroxide, it would be 1 times 10 to the negative, and since the POH is 6, it would be -6 here. This one, you would do the same thing, except this time it's a hydrogen concentration. So if the pH is 3, the hydrogen concentration would be -3. So if a solution had a pH of 2, that means 1 times 10 to the -2 would be the molarity for the hydrogen concentration. But to find out the hydroxide concentration, we would have to subtract 14 minus 2 is 12. So 12 is the pOH. So if we know the pOH, that means the hydroxide concentration is 1 times 10 to the -12. So going back and forth, it's really just looking at what they give you. If it's hydrogen, that's going to be the pH. So 1 times 10 to the -2. If they give you pH and they want to know the OH concentration, you have to figure out the pOH first. You can't just do 1 times 10 to the -3 because this is the hydrogen concentration. So 14 minus 3 equals 1. So this would be, 11, Hansen math. 1 times 10 to the -11. Questions like this, which is the strongest acid? That's basically saying on the pH scale, which is closest to 0. So for these, you're actually going to have to change it to pH. Since this is the hydrogen concentration, the pH is 4. Since this is the hydroxide concentration, the pOH is 11, which means the pH is 3. This is the hydrogen concentration, so the pH is 11, which means that's a base. And a pH of 12 is also a base. So closest to 0 on the pH scale would be this one. You'll do the same thing for 15, but this time it says what is the strongest base. So on the pH scale, you'll make sure everything is in pH, and you'll want to know which is closest to 14. If it's asking which is closest to neutral, it's asking which has a pH closest to 7. And if it's asking which is most similar to acid rain has a pH of 5.6. That was in our notes today. So you may have missed that. On number 18, it says which has the closest pH to oven cleaner. That should also be in our notes somewhere that oven cleaner has a pH of about 13. So we want to know which one of these is going to be closest to a pH of 13. And again, you would still change everything to pH. The pOH on this one would be 6, which would mean the pH is 14 minus 6, so that's 8. This has a pOH of 1, which means the pH is 13. So to me, that's our winner, winner, chicken dinner. This has a pH of 1, which is very acidic, so it cannot be B. And this one here has a pOH. Oh wow, that's the same thing we have for B. So this would actually either be B or D because both of them are correct. The pOH would be 1, which would mean the pH is 11. So this is a typo problem. These are the same. So I'm going to go ahead and let y'all finish 19 and 20. For the table here, they just want you to write, if it's a hydrogen concentration, it's 1 times 10 to the negative 3. And for the hydroxide, it would be 1 times 10 to the negative whatever adds to 3 to make 14, which is 11. And again, POH is 3, so that means that the pH is 11. So that would be the hydrogen concentration would be 1 times 10 to the negative 11, and the pH would be 11. Okay, I got pH 11 by saying 14 minus 3 is 11. So you'll go through and you'll answer these questions. They're all slightly different. I'll do one more since y'all think the ones towards the bottom are harder. This has a POH of 8, which means it has a pH of 6. That means this is 1 times 10 to the 6th. And this one is 1 times 10 to the 8th. This is really the big goal of this. If we give you a concentration of hydrogen or hydroxide ions, you should be able to tell us if the solution is likely to be acidic, basic, or neutral. For here, since this is our hydrogen concentration, the pH is 2, which is an acid. Again, this is a hydrogen concentration, so the pH is 10, which is a base. Here the pH is 7, so it is neutral. Okay. It might be good practice up here as well to write acid. pH 11 is a base. pH 6 is slightly acidic. And again, the table below is still asking the same thing. We give you one clue. We expect you to be able to solve for the other 3. So if the pH is 3, then 14 minus 3 would give us a POH of 11. 1 times 10 to the negative 11 would be the OH concentration, and 1 times 10 to the negative 3 would be the pH. Thank you for joining us for the homework assignment. If you need more help, there's tutorials in the morning or afternoons each day. Thank you.